Hey everybody, let's talk about topic 4 for Unit 6. This is finding the length of an arc and the area of a sector. So we're still talking about circles, and when you have angles that are formed within circles, you have a portion of that circle. And in order to do this lesson, we first now finally have to learn what is a radian. And so we have to know that an angle or an arc can be measured two different ways. It can be measured in degrees, or it can be measured as a radian value. So it's very similar to like inches versus centimeters. Those are two different units of distance. Radians and degrees are two different units for measuring the amount of a rotation. So I have a link to a clip right here, and I don't think it works through the PDF, but I'll link it in Classroom, and that is this video right here. So when I play this video, you see we have a grid and there's a radius. And the circle is created by spinning that radius, rotating that radius at 360 degrees. Now, the red segment represents the length of the radius, and a radian measure happens when you have this happening right here. So that you take the length of the radius and you kind of fold it along the edge of a circle. So what you see right here, that rotation is equal to the length of one radius. And the length of one radius is equal to the measure of one radian rotation. So one radius length is equal to one radian rotation. Okay. Now, if we copy that, so this angle that's created here, that angle is measuring 1 radian. Now, the amount of degrees there is very close to like about 60 degrees, but it's not exactly 60 degrees. And so in degrees, it's like I said, about 60, but in radians, it's exactly 1 radian. Now, if you copy and paste this and go, here's a second radian, and then there's a third radian. Let me pause it right here. Now, do you notice how by creating, there's exactly 3 radian measures there? And you notice how that's not quite half a circle? So do you know how far it is from this point right here on the rotation to just a little bit more to complete that exact semicircle? Would you guess that it's about 0.1459 something? And so if you have seen this very famous number before, we just saw it in March, it was on the calendar, it's 3.14, they call it Pi Day. That's because pi is a unit of radians. And what pi is exactly, pi radians rather, is exactly 180 degrees. So you see, when we get to this point, we're at 3 radians. If you went at that extra like 1.4, 0.14, that would take you all the way to 180 degrees. Now, when we keep going here, so that little bit, that's the remainder to get to 180. But now, as it says, that is exactly pi radians. A complete 360 degrees is not just 1 pi, but 2 pi's. 2 180s equals 360. So 2 pi radians is 1 complete rotation. So in degrees, a rotation is 360 degrees. When we talk about radians, a rotation is 2 pi radians. So remember this right here, that 1 radian is equal to the length of the radius of the circle. And very rarely will you see a radian measure that's just like the number 1 or the number 2 or the number 3. Most often, radian angles are in terms of pi, because pi is like how much of that circle they're covering. So pi radians is exactly the same as 180 degrees. Okay, so that's the difference between measuring a rotation in angles, measuring a rotation in degrees versus radians. Next, we're going to look at how the radius of a circle, along with the measure of a central angle. Now remember, what's a central angle? That's an angle where the vertex of that angle is exactly at the center of a circle. So we're looking at the radius of a circle along with the measure of a central angle and how that's going to affect not the measure, but the length of an intercepted arc and the area of the sector formed by the central angle. Okay, so now what you see on the table here is we have measuring an angle in degrees or measuring an angle in radians. And basically, I'm making this a ratio. How much is the angle measure out of the whole? So it's like part out of whole. And what we're going to see is that we're going to use these ratios to kind of create a proportion to solve for how long an arc is or how much area a sector of a circle covers. Okay, so what it's going to look like is like this here. So both of these that I put in this pink box right here, this is the angle measure. So the angle can be measured in degrees as the measure of the central angle out of a whole 360 degrees, or the measure of the angle in radians out of the whole 2 pi radians. Because remember, 360 degrees is equal to 2 pi radians. Now, what we're going to do is we're going to figure out how are we measuring the angle, and then we're going to compare that to either the circumference or to the area. And when we're looking for arc length, this is part of the circumference or the perimeter of the circle. And circumference is out of 2 pi r. This multiplying 2 times pi times the length of the radius is how you determine the entire circumference of a circle. The formula for the area of a circle, how do you calculate the entire area of a circle, is pi times the length of the radius squared. And the sector area is part of the area of the circle. So when we're looking for area, we're going to say, what's the part of the area out of the whole area of the circle? When we're looking for arc length, it's what's the part or the arc of that circle length out of the entire circumference. So here's a couple examples. One of them's in degrees, the next one's going to be in radians. So the first one, we're looking at, here's a circle, and it says we need to find the area of this shaded sector, and we're going to round that area to the nearest tenth, and also find the length of the highlighted arc to the nearest tenth. So we're going to do two different parts here. Let's start with part A and finding area. So the two things that I want to pay close attention to, one is that this right here, the 5 centimeters, that's equal to the length of the radius of the circle. And the second thing is they give you this angle measure right here, the measure of this central angle. See, it says that this is called circle D. D is the center of the circle. So this is a central angle measuring 60 degrees. We want to first determine what's the area of this circle. And so since we're measuring our angle in degrees, I'm going to look at the angle measure in degrees. So I'm going to say for area here, we're going to say that the angle in degrees out of 360 degrees is equal to, now we're going to compare that to area. Area is the part of the area, which is what I'm looking for. So I'll say sector area out of pi r squared. So now what we're going to do is substitute. What's the measure of the central angle? It's 60 degrees. So we'll say 60 out of the whole 360 is equal to this area that I'm looking for right here. I don't know how much area is covered in this circle out of the entire area. So the entire area is pi times the radius length 5 squared. Okay, now we're just going to solve this equation to find what the area must be. So the area of that section is 13.1 square centimeters. Now, the next thing in part B, we want to determine what is the length of that arc. Now, here's the thing, is I know that the measure of this arc, if I was going to measure it, it would be exactly 60 degrees because the measure of the intercepted arc is equal to the measure of the central angle. But I don't want the measure of the arc, I want the length of the arc. How many centimeters is that arc, not how many degrees is that arc. So let's figure that out by writing a new equation. But see, I'm still measuring the angle in degrees, so I'm going to still set up the same angle relationship here, that the measure of the angle in degrees is out of 360 degrees. Okay, but this time I'm going to set this equal to not area, but arc length. Okay, we're looking for arc length this time, not sector area. out of, so arc length is a part of the circumference, that's the arc length, out of 2 pi r. So there's my equation. Now I'm just going to substitute and then solve. So the angle is still a 60-degree angle out of 360 total degrees. But now my arc length is what I'm looking for. So I'll just say length here. Try to write it a little nicer this time. Length out of 2 times pi times the radius length 5. Okay, now when you're solving this proportion, you can just cross multiply or you can just go to your equation solver and solve that way, because all we're looking for is we're just approximating pi anyway, and we're trying to find what the area, or sorry, what that sector, that arc length is to the nearest tenth. So the length of that arc is 5.2 centimeters. So remember how I was talking about earlier that 1 radian measure is about 60 degrees. So if 60 degrees was equal to 1 radian, then the length of this arc from C to E would be equal to exactly 5 centimeters. But it's actually, this length is a little bit more than 5 centimeters. So 1 radian measure is actually a little bit less than 60 degrees, but that's about how much it would be, okay? So there's finding sector area and arc length when we are given an angle that's measured in degrees. Now let's take a look at what happens if I'm given my angle that's measuring in radians. So in example 2, I have a circle with a radius that has 8 centimeters and a central angle measuring 7 pi over 4 radians. Now, one thing, if I want to just, I don't have a diagram, I'm going to have to draw my own diagram, but I want to consider this. 7 over 4 is, it's like 1.75. Okay, so 1.75 pi is not like it's more than 1 whole pi, not quite 2 pi. So I'm just going to try to keep that in mind when I'm estimating what my circle should look like. So this is my estimation of my picture here. So I've got a circle. It has a radius length that's 8 centimeters and 7 pi over 4 radians. Again, 1.75 radians is like not quite 2 full radians. 2 full radians is exactly 360 degrees. So 1.75 radians would be 1 radian is exactly 180. 1.5 radians would be right here. So 1.75 is kind of like right about where I have it here. So that's a whole rotation. So we're looking at more than a 270 degree. It's like a 315 degree angle that we're trying to talk about here with my central angle. Now, for part A right here, when we're looking for the area formed by this central angle in terms of pi, so the area means I'm looking for most of this circle. I'm only excluding this little piece of pi here. I'm taking more than half of it, almost the whole thing right there. So I'm trying to find all of this area, and then I'm going to find the length from like the beginning of the rotation to the end of the rotation right here. Okay, so I am trying to determine area, and when I'm looking for area, I'm going to compare the angle measure, whether it's in degrees or radians. This time we're talking radians, and compare that with the area. And the area doesn't depend on the way that we're measuring the angle. It's just this is how we find area. Area is part out of pi r squared. So I set up my equation as my angle measured in radians out of 2 pi radians is equal to my sector area out of pi r squared. That's the entire area for the circle. So now I'm just going to substitute and say my angle measured in radians is, wrong color. My angle measured in radians is the 7 pi over 4. Divide that by 2 pi is equal to my sector area. That's what I'm looking for. So that's my unknown. Divided by pi r squared. So it's pi times the radius length 8 squared. Now, this one says we have to find this area in terms of pi. What that means is that my final answer should include a pi with it. Now, if you look at how this is going to work out with the cross multiplying and all that, we have a pi right here with the 7 pi over 4, and we have a 2 pi down there, and then we've got a pi over here. So basically, this pi that's right here will simplify with that pi that's over there. So you have 7/4 being divided by 2, and then the area is being divided by, 64 pi. And so what we're going to end up getting is when we cross multiply, and we're going to then divide by 2 to get the area, we'll end up with this. The area is 56 pi centimeters squared. So when it says in terms of pi, that means that pi should be present in your answer. Now let's talk about arc length. So when we're looking for arc length, I want to look for this portion of the circle right here that I'm tracing along. That's the distance that I'm trying to measure now. And again, we want to find the length of that arc in terms of pi. So again, that pi needs to be present in my answer. Everything else is going to be the same. So I set up my equation. Since my angle was measured in radians, I chose the ratio angle in radians out of 2 pi radians. And this time I'm looking for arc length, so it's part of the circumference, part over 2 pi r units. So here it goes, and I'm going to start with this 7 pi over 4 again for my angle measured in radians. Divide that by 2 pi is equal to the arc length over 2 times pi times the radius length 8. So again, what happens is we have a pi right there canceling with a pi right there, and we have this same 7 over 4 and all that. We just don't have r squared, it's just 2 times r instead. So I'll go ahead and solve this, and we will see what we get. So the length of that arc is 14 pi centimeters. So it's like 14 times 3.14 centimeters. There's the length of that radius, or the length of that arc. Okay, so now you're going to see some questions where it's not just going to be telling you the length of the radius and telling you the measure of the central angle, but always you're going to have enough information that you can figure out what it is that you're missing. Just go back to these equations that are these ratios, whether you're talking about the angle measure in degrees or the angle measure in radians. You're going to choose one of the ratios determining on which one we're measuring with. And then if you're given arc length, then you should use this ratio. If you're given area, then you should use this ratio for area. But just set up your proportion based on how you're measuring your angle or how you want to measure angle and what other information you have or you want. Okay, good luck with your Desmos, and be ready for the test.